Okay, today's video is about angle relationships. So, several vocab in order to help us solve for algebra. So our first relationship is an adjacent angle. This is when two angles are next to each other, like so. They could be on the same line, they could have a ray, they could be bisected, but it's when two angles are next to each other or touching, and they share a common vertex and a common ray, okay? And have no common interior points, as seen here. Like this is the interior point of that angle, this is the interior point of that angle. And we use that in order to solve angle addition postulate problems, or part plus part equals whole problems. So when we have adjacent angles, your strategy is more than likely to use part plus part equals whole. That's where at least you should start. In this example here, we have two angles that are next to each other. We have this angle B. We have this angle that is 65 degrees. And later we'll learn what happens when they're on a straight angle or a line. But we'll get to that later in the video. Next up is complementary angle. Complementary angle is an angle where two angles add together and equal 90 degrees. So that's the key takeaway there, that it's 90 degrees. My vocab today is going to be in pink, math in blue, clarifications in black. So notice that we have two adjacent angles, and the little box tells us that the total is 90. So we have a 40 and a 50 degree adjacent angle that adds up to 90. We can also have two separate angles like so. In the example below, we have this box that tells me that's going to be 90. Since they're adjacent angles, it's probably going to be part plus part equals whole, where the whole is going to be 90 degrees, and each part is 6x plus 4 plus 26 equals 90. When I add that together, I get 6x plus 30 equals 90. 6x is equal to 60. X is therefore equal to 10. And I get that by doing some various things, like on this step I combined like terms. Then I subtracted 30 from both sides for the subtraction property of equality. Then I divided by 6 on both sides, or the division property of equality, if I was doing the algebraic proof. Okay? Next up is perpendicular. Perpendicular lines are lines that intersect to form right angles. It's denoted by this symbol, which looks like an upside down T. Okay? For example, segment AB here is perpendicular to segment CD. Would mean that the segment AB is perpendicular to segment CD, and a right angle would be formed. Notice the box tells us a right angle. Do not assume that there is a right angle unless there is a box, or it tells you that the angles are perpendicular or complementary. Okay? I have lots of students that are still assuming things, and that will get you in trouble later. Next up, we have supplementary angle, which is very similar to complementary, except instead we have two adjacent angles that add together to form 180 degrees. Okay? They could be adjacent angles, or they could be two separate angles like this. But the key thing is that the angles add up to 180. Remember, our adjacent angles are going to equal, are going to mean that we use the part plus part equals whole. But so does our separate here. So in our example, we have angle 1 and angle 2 are supplementary. Angle 1 equals 5x plus 2. Angle 2 equals 2x minus 4. Solve for angle 1. Okay? So I need to solve for the measure of angle 1, which is equal to 5x plus 2. But I have to use part plus part equals whole before I can do that. So one of my parts was the 5x plus 2. The other part was 2x minus 4. And since it said they're supplementary, I know that they're equal to 180. And so now I do all the math. I get 7x minus 2 is equal to 180. And then I can get 7x is equal to 182, which means that x is going to equal, did I do something wrong? No. Oh, yep, 182 and 42. Okay, so x equals 26. Sorry for that pause. I had to think about that for a second. Okay, so once again, I combined like terms. I then, this would be substitution. Then I combined like terms. Then I did the addition property of equality. And then lastly, the division property of equality, where I divided both sides by 7. Okay? Next, we have a special kind of supplementary angle, which we see here, which is known as the linear pair, which is the adjacent angle form of supplementary. The reason we call it a linear pair is because these angles are supplementary, but they're adjacent and on a line. Okay? The two angles are on a line, and therefore they are going to add up to 180 because a line is that straight angle. So we know that a line forms 180 degrees. So in this example here, notice we have two angles that are on the same ray. So we can say again, part plus part equals whole. We can say x plus 11 plus 5x plus 1 equals the whole of 180. We can combine like terms, and we get 6x plus 12 equals 180. We can use the subtraction property of equality and get 6x is equal to 168. Yeah, 168. Then we can use the division property, and we can get x is equal to 228. So we can get x equals 28 with that. Okay? And that's how we handle supplementary and linear pairs. So very similar. Okay? So remember, a supplementary angle and a linear pair are only the same if the angles are adjacent. So that's a key takeaway. Supplementary and linear pair are the same if angles are adjacent. Okay? And our last guy is vertical angles. And vertical angles are non-adjacent, so they do not touch. And they're formed by intersecting lines. The opposite angle pairs formed by the two lines and line segments intersecting are congruent to each other. So as we see here, notice that this side and this side, the left and the right here, are congruent, and the top and the bottom are congruent. But notice that the adjacent angles are not. The adjacent angles are not the same. So where it says which angles are congruent below, we have to look at our intersecting lines that cross. So we see that 1 and 4 would be congruent. And then we can see that 2 plus 3 is congruent to 5. So in this case, we would have angle 1 is congruent to angle 4, and we would have angle 5 is congruent to angle 2 plus angle 3. Okay. An example of this is like our bisector problems, where we have two congruent angles because these are vertical angles. And so therefore they are equal, so I can say 7z plus 7 is equal to 9z minus 7, because part equals part. So then I can subtract 7 from both sides. I get 7z is equal to 9z minus 14. I can subtract 9z from both sides, and I get negative 2z is equal to negative 14. I can divide both sides by negative 2, and I get z is equal to positive 7. Okay? And that's how we handle vertical angles. Now here is our proof, and we're going to be doing a lot more geometric proofs and not as many algebraic proofs, but here is another algebraic proof. So here we have angle 1 and angle 2 are complementary. angles. We're told that angle 1 equals that and angle 2 equals that. That's all given. That's the problem telling us what to do. So we use part plus part equals 90, and we add the two measures of the angles, which is the definition of complementary angles. This is our new guy. Then we plug in our numbers, and we solve just like we would if it was a part plus part equals whole problem. And we solve everything. We go through it all, substitution property, combine like terms, subtraction, division, substitution, etc. Okay? And so that's how we handle the proofs for today. And that is all the angle relationships that we need to know to be successful.